Alright, in this video we're just going to review a few problems to get you ready for your test. So let's go ahead and take a look. Notice on the left hand side I have a calculator just like the one we have in the room. And then on the right side I'm going to do the problems that are circled. On this first problem, number 2, it says find the value of D that makes the statement true. When they say that, they're actually just asking you to solve for the variable. So they're wanting you to solve for D. That whenever we find that value that makes D true, then it's going to be solved for D. So let's go ahead and take a look right quick at how we do that. Now the first thing I want to do is I want you to think about PEMDAS, right? Something that you learned a long time ago, most of you. And it just means that you deal with parentheses first, exponents next, then multiplication and division, and then addition and subtraction. We're going to go in that order, and we're going to solve this from left to right. So I do got to deal with the parentheses before I can go any further. The way we deal with the parentheses is we distribute what's in front of it, including the sign that's in front of it. For instance, on this front one right here, we have 1 over 4. Now, it doesn't have a sign in front of it, which means it's positive. So we're going to distribute that to both terms that are inside of the parentheses. On the right side, we're going to do the same thing, with the exception of we have a negative sign in front of that 3. So we're also going to distribute that negative sign with the 3. So it'll be negative 3 times D and negative 3 times negative 12. Now our goal when we're doing these problems is we want to get the variables, and I'm going to be doing my variables today in black. So the variables, we want them on the left side of the equation. And then in red, I'm going to be doing what we call the constant, which is the value that doesn't contain a variable. And we want all those values on the right. So all the things that are red will be on the right side of the equal sign. All the things that are black will be on the left side of the equal sign. And this will make more sense as I go through it. Now I am going to draw a line through the equal sign so I can kind of make sure that I keep both sides of my equation balanced. In other words, whatever I do to the left side, I'm going to want to do that to the right side. That's very important as I'm working on this. And so I'm going to go ahead and I'm going to get started. So let's take a look. I'm first going to go ahead and take 1/4 and multiply it to D. Now there's a couple ways that we can do that, and I want you to think about it, and I'm going to write this down so you can kind of see what's happening. When I draw this little arrow showing that I'm distributing, what I'm really doing is I'm going 1/4 times 16D. And now I can't multiply. If I put a letter in the calculator, it's not going to multiply it for me. So I'm really going to leave this D off, and it's just going to be written in my final answer. What I'm really multiplying is 1/4 times the coefficient of D, which is just the number that's in front of the letter D, which is 16. So this is 1/4 times 16. So I'm going to go ahead and I'm going to use this calculator over here to do it. You notice it turned off for a second. I just went into your practice star that you can access online because I want to use a calculator that's very similar to the one that you already have. And so let me pull up a calculator. And I'm going to type it in. Now there's a couple different ways you can type it in. One way is that you could go ahead. Let me clear this. Is you could type in alpha y equals, and it gives you a fraction bar. So notice that I have a fraction bar in here, and I could type in my fractional value in there. So 1 over 4. If you like using those fraction bars, right? So you can see it looks just like 1/4. And then I can do times 16. So I'm going to hit times 16. Now once I do that, I'm going to hit enter. Notice it did all the math for me, and it gave me a 4. So I'm going to go ahead and I'm going to write that down. So 1/4 times 16 is simply 4. So this, once multiplied, actually gives me 4D. Now I'm going to take that 1/4 and I'm going to multiply it to positive 4. So once again, I'm going to create my fraction bar. So I'm going to hit this alpha button, and then I'm going to hit the y equals. And notice option 1 shows a fraction, it shows division here. So I'm going to hit 1 for option 1, get my fraction bar. And I'm going to put 1 over 4. And I'm going to click to the right to get out of the denominator. And then I'm going to go ahead and multiply that times 4. So times 4. And it gives me 1. So I'm going to go ahead and put on there it's a positive 1. So I'm done. I have distributed my 1/4 to the 16 and got 4. Distributed my 1/4 to the positive 4 and I got 1. And now I need to do the same thing to the right side. Now the only thing is I should have put this 1 in red. So I'm gonna redo that 1 in red. So my constants are red and my variables are black. So we're going to take this negative 3, multiply it to d. And so what we're really doing here is we're saying negative 3 times the letter d. Now the good thing is anytime you have just a variable, there is an invisible 1 in front of it. So imagine there's a 1 right here in front of it. So this is really just negative 3 times 1. And most of you, right, you have that intuitively. You know that any number times 1 is just itself. But if you want to throw it in the calculator, you always can to check it. So negative times a positive is just going to stay negative. And so that's going to be negative 3d. Then I'm going to take this negative 3 and I'm going to multiply it times negative 12. So now we have two constant values being multiplied. So negative 3 times negative 12. And we can check that in the calculator. Negative 3 times negative 12. And it gives me positive 36. And that's because a negative times a negative is a positive. Now this is just turned into an 8th grade math problem, right? So we have 4d plus 1 and negative 3d plus 36. We're going to continue the process of trying to move all variables to the left and all my constant values to the right. So I'm going to start, because I like doing my problems from left to right, I'm going to start on the left and I'm going to move this positive 1 over to the right. Now to move something to the other side of the equal sign, we have to use inverse operations. So I'm just going to write that right here. Inverse operations. And what I mean by inverse operations is we're doing the opposite. For instance, the inverse of addition is subtraction. And the inverse of multiplication is division. So you just got to remember that. You're doing always the inverse. So this is addition, right? So we have to subtract it. So I'm going to subtract 1. And whatever I do to one side of the equation to keep it balanced, I do to the other side. So on the other side, I'm going to subtract 1 as well. 1 minus 1 equals 0. They cancel. 36 minus 1 gives me 35. Now, just like I moved the constant value to the right, because I wanted everything red on the right and combined, I want to move my variable over to the left and then combine them as well. Now, this is minus 3d, and the opposite of subtraction is addition. So I'm going to add 3d to both sides. So that becomes 0. So we like to say when it becomes 0 that it cancels out. And then we have 4d plus 3 more d. Well, 4 plus 3 is going to give me 7. So this is 7d. Now in my final step, what I got to do here is I got to go ahead and I got to get rid of this coefficient of 7 that's in front of the d, right? We want d to be all by itself. And so I'm going to divide by the coefficient. So I am going to divide by this 7 on both sides of the equation. Now any number divided by itself is always 1. So that just becomes 1. 7 equals 7 one time. And that leaves us with 1d. And that's going to be equal to however many times 7 can go into 35. So I'm just going to put 35 divided by 7. Hit enter. And notice it gives me 5. So d is equal to 5. Now, let's go ahead and go to our next problem. And so you can see another example. I'm going to move this up, but I'm going to follow the same process. Variables on the left, constant values on the right. And let's try this next one. First, we want to go ahead and distribute this negative 2 over to negative c and to negative 7. So I'm just going to circle it. So I got negative 2 times negative c. So negative 2 times negative, and I'm going to put a 1 in front of it, right? Because it's really negative 1c. And when I do that, if you put that in the calculator, if you're not good at memorizing what happens with these signs, right? A negative times a negative is a positive. But if you struggle with that, just test your idea on the calculator. Negative 2 times negative 1. and that's going to give me a positive 2. So I'm going to write this as 2c. And then I have negative 2 times negative 7. So negative 2 times negative 7. And it gives me positive 14. And then that's going to be equal to, I'm just going to bring down negative 6c. Now, we do have some distributive property going on right here, so we need to distribute this positive 5 to both terms on the inside of the parentheses. So positive 5 times 3c. So I'm going to write that down. So positive 5 times 3c. And most of you probably know what 5 times 3 is, right? But if you don't hesitate to use the calculator. And it's going to be 15. So I'm going to go ahead and say this is going to be positive 15c. And then we're going to take this positive 5 and multiply it to the positive 7. So positive 5 times positive 7. So you're going to notice that you always see me using this calculator when I'm going through here. And that's because I had some learning issues as I was going through school, and I have trouble memorizing multiplication and division, like times tables. It just doesn't work for me. It doesn't always stick in my head, and so I use the calculator to check everything. But I actually remember the processes of mathematics really well. So I can solve many problems, and I don't have an issue with that. Did really well in college in my math classes, but I did use my calculator throughout to make sure that the calculations I was making was accurate. So don't be afraid to use that calculator. It's available to you on your STAR test throughout the entire test, and you can use it for every operation that you do just to double check and make sure that you're getting it right. So now that you see we have the distributive property taken care of, right? So we got that done. We multiplied that 5 to the 3, the 5 to the 7. We got our values, the negative 2 to the negative c, and the negative 2 to the negative 7. So now what we want to do before we start shuffling anything is we want to combine anything that's a like term. For instance, I notice that over here I have negative 6c and positive 15c. So instead of moving these one at a time, I recommend go ahead and putting them together since they're already on the same side. So we're just going to rewrite these. So when I say put them together, just imagine you're taking a coefficient, right, and you're combining them. So negative 6 plus 15. So negative 6 plus 15. And it gives me positive 9. So I'm going to go ahead and I'm going to write that down. So I have 9c. I'm just going to bring down the positive 35. And I'm going to bring down my 14, that's positive, and my 2c. So I'm rewriting it. And the reason I rewrite it is because I like to keep everything lined up. Now it just really became an 8th grade math problem again. So what I'm going to go ahead and do is I'm going to go ahead and use my inverse operations now to get all my constant values on the right and to get all my variables on the left. So I want to move this 14 over to the right. To move 14 over to the right, I have to do the inverse operation of adding 14, which is going to be subtracting 14. That becomes 0. And if I subtracted 14 from the left, I have to subtract 14 from the right. So 35 minus 14. And I have a 21. I'm also going to subtract this 9c on the right and subtract it on the left. So anything minus itself is 0. And minus 9c. And remember, we can just subtract our coefficients. Just leave the c out of the calculator. So we got 2 minus 9. And that leaves me with negative 7c. Now we're almost done, right? The only thing that we got left to do is we got to get rid of this coefficient in front of the c. In other words, I can't have a negative c. I just want to have a positive c all by itself. So I'm going to go ahead and divide out this negative 7. I'm going to do that on both sides. And I know anything can go into itself one time. That simply just leaves me with c equals, and then I'm going to go to my calculator and I'm going to do 21 divided by negative 7, and it gives me negative 3. So that's my final answer. And that's how we solve that one. So let's take a look at another problem. So in this problem here, I want you to notice it looks very similar to what we just got through doing, but notice it has an inequality symbol. Do you see this symbol here? And there's really just one thing different that you're going to do that you really got to remember when you're dealing with a inequality, is that when you have this inequality symbol, you're going to treat it like an equal sign when we're solving it. However, if you divide by a negative, you got to flip the sign. And so it's been a while since you did that. The last time you dealt with inequalities as far as solving them in mathematics would have been 7th grade. You would have dealt with inequalities. In 8th grade, we don't deal with solving inequalities. We just solve equations. And then you come to 9th grade and you got Algebra 1. And now all of a sudden you have to remember this rule. So just remember that if you divide or multiply in your final step by, I'm going to put by a negative value, flip the sign. Now, I don't know if this one's going to end up having a negative value or not. Hopefully it does so that you can see why I would flip the sign. If not, there's a second example on here, and we'll go ahead and do that one. So I'm going to start out the same way as always. I see that I have some parentheses here, and I want to take care of that distributive property. So we're going to take our 5 and we're going to distribute it to what is inside there of the parentheses. And so this is actually going to be 5 times 6x. And if I multiply that out, right, I just simply going to multiply the coefficient times my constant value. So 6 is the coefficient, and it's being multiplied to my constant value of 5. And it tells me that it's 30. And so therefore, this is actually 30x. Then I'm going to take that 5, and I'm going to multiply it to positive 9. So 5 times 9. And that's going to give me 45. So 5 times 9 is positive 45. Now, there is no distributive property on the right. I'm just going to simply bring down my inequality symbol and my variables. So I have 17x, that's positive. I have negative 33 is another term. And then I have positive 16x over here. Now, before I go ahead and I start trying to move constant to the right and move my variables to the left, I want to go ahead and see if there's anything I can combine. Now, I do notice looking at this right here that I can actually combine this 17x with this positive 16x. So I kind of draw this little mark here, just showing we're going to combine it and write our answer underneath. So if I have 17 x's and I add 16 more x's, that's like saying 17 plus 16, and that's going to give me 33. So actually, this just becomes 33x. So notice I got rid of two terms by just combining them together because they're alike. Now there is no other constant to combine on the right. Therefore, I'm just going to bring down the negative 33. Bring down my symbol and bring down my 45. That's positive. And my 30x. That's positive. All right. So now, right, we're back to a simpler type problem. I'm going to go ahead and draw my line through my inequality symbol, treating it like an equal sign. And I'm going to start by moving my constant value of 45 to the right side. Now that's a positive 45, so we're simply going to subtract it, which is the inverse operation. I am going to do it on both sides because we will always want to keep our equation, our inequality balanced. Now 45 minus 45 is 0 on the left, and negative 33, I'm going to put that in my calculator, negative 33, plus, because we're combining these together, negative 45. Hit enter, and it tells me it's negative 78. So I'm going to write that down here, negative 78. All right, now we want to move this variable over to the left. So we have 33x, and so I'm going to subtract 33x. So that cancels, subtract 33x on this side. And once again, we're combining 30 plus negative 33. So 30 plus negative 33. And it gives me negative 3. So negative 3x. So we're almost done. We can't have a negative 3 in front of our x though, right? We always have to have a positive variable with a coefficient of 1 in our final answer. So the way that I get rid of that coefficient is I do the opposite of what's happening. Right now, negative 3 is being multiplied to x. That's what negative 3x means. A coefficient is a multiplier. So I do the opposite of multiplication, which is division. So I'm going to divide by -3 on both sides. That'll go into itself one time, simply leaving me with just 1x. And now I'm going to do -78 divided by -3. Now I do want you to notice, just out of habit, I put an equal sign here, but I forgot. We actually have an inequality sign. So my answer on my calculator, notice it's positive 26. So I'm going to write a 26 on here. But I want you to notice that we actually had to divide by a negative. And remember I told you in the beginning, if we divide or multiply by a negative, we got to flip the sign. So this sign right here, this less than is actually going to change. And so let me go ahead and just get rid of that. So this less than is going to change. I'm going to write flip right here. We're going to flip it and it's going to change from a less than to a greater than. The reason is because we divided out a negative coefficient on both sides. And the rule says if we divide or multiply in our final step by a negative value, we must flip the sign. So instead of x is less than 26, we have x is greater than 26. And that's our answer. Let's go ahead and go to number 6 right quick. We got a couple things going on here. Notice that we have two situations where we got two distributive properties occurring. And we have two constant values being added on both sides of the equation. So it's going to be a little extra work, but let's go ahead and do that. We are going to start with addressing this distributive property first. So I'm going to circle my number that's in front of the parenthesis that we're going to distribute, and we're going to start doing that. So this right here is actually 8 times 1x. And if I were to put that together, it's basically just 8 times 1, which is going to give me 8. So this leaves me with 8x's. Then I'm going to take this 8 and I'm going to multiply it to -5. So positive 8 times -5. And for that, I'm going to put it in my calculator. Because as I was telling you earlier, Mr. H doesn't really remember all his times tables. And right, we have a calculating device that'll take care of it. So we have -40. And then I'm simply going to add 17 to it. And notice with the 17, right, I'm just bringing it down. I just put plus 17. There's no distributive property or anything that's going on. And we'll combine those in just a moment. But first things first, take care of the parentheses first. Now we're going to take this 2 and we're going to multiply it to 2x. So I have 2 times 2x. Now I know 2 times 2 is 4. So that's going to give me 4x. And then I'm going to go ahead and take this 2 and multiply it to positive 1. So 2 times 1, and I know that 2 times 1 is just going to give me 2. So plus 2. And now I'm going to bring down my constant value of -24. Alright, so we're almost ready to go in and start moving things from side to side, right? Getting our variables on the left and getting our constant values on the right. But before we can do that, let's combine the things that we can combine to make this a little bit simpler equation to deal with. So I'm going to combine the -40 and the 17. So I have -40 plus 17. Hit enter and it gives me -23. So I'm going to go ahead and write down here -23. I'm just simply going to bring down my 8x. The arrows are just showing you that I'm just sliding it down. And this is equal to, I'll bring down my 4x. And we want to go ahead and combine the positive 2 and the -24. So let me do positive 2 plus -24. And it gives me -22. Now, I have all this written out. And so what I want to do now is I want to go ahead and start moving variables to the left and constant values to the right. So I'm gonna start with my constant. I'm gonna move this 23 to the right by doing inverse operations. Since we're subtracting 23, we're gonna add it. That makes a 0 value. It cancels out. I'm also gonna add 23 to this right side, and so I can simply go to my calculator and put, well, I got -22 plus 23, and it's gonna give me 1. So this is a value of 1. I'm then going to go ahead and move my variable to my left. Now that's a positive 4x, so to move it, I do the inverse operation, which is subtract 4x. That leaves me with 0 variables on the right, and then I subtract 4x from the left, and 8 minus 4, I can do that one in my head. That is simply just 4x. Now, as usual, we do have a coefficient that's greater than 1. We can't have that, so I need to go ahead and divide out this coefficient, right? Because that's the inverse operation of multiplying x by 4, so that I can get rid of it. So divide by 4, divide by 4, and I'm simply left with x is equal to 1 over 4. I would say in algebra, it's very ideal to just leave things as a fraction. A lot of the things that you're going to do in algebra, especially when you're graphing inequalities and graphing linear equations, is just easier, in my opinion, to deal with a fraction because you're looking at rise over run when you're graphing. And so I would tell all my students, all the years that I've taught algebra, which are many years, I always tell them just leave it as a fraction. Don't convert it to a decimal unless you're asked to convert it to a decimal. So we'll just leave that as 1 over 4. Let's move to the next problem. All right, on number 9, notice this is another inequality, and we have some distributive property going on here. So we're going to treat it just like an equation. I'm going to take what's outside, and I'm going to distribute it to the inside of the parentheses. In other words, I have negative 7 times 4x. And when I go to my calculator, and I do negative 7 times my coefficient of 4. All right, so I'm going to go ahead and I'm going to write negative 28x. All right, so now what we're going to do is we're going to go ahead and distribute that negative 7 to the positive 9. So negative 7 times positive 9. So I'm going to get my calculator and I'm going to do negative 7 times 9. And it gives me negative 63. Now I'm going to go ahead and bring down my inequality symbol. And at this time, I'm going to bring down these last two terms. Notice there's no distributive property on the right-hand side, so we simply bring down our terms and continue with the problem. Now I'm going to draw my line through my inequality symbol because at this point, right, we only have one variable and one constant on each side. So it's time to start moving things from side to side of the inequality. So I'm going to start by moving my constant over to the right. So I'm going to do the inverse operation of subtracting, which is adding. I'm also going to add 63 to the right side of the inequality. And I'll put that in my calculator. I have negative 2 plus 63. And it gives me 61. And then I'm going to go ahead and take this negative 28x, right? I'm going to do the inverse operation, which is I'm going to add 28x. So it zeroes out on the right. And then I got to add 28x on the left. And when I do that, I have negative 28x plus 28x. And that's going to leave me with 0. Now, once I've done that, notice the only thing I got left here is I have my inequality symbol. I want you to notice also that my variable has went away. So if you notice, right, I don't have a variable here. So I just have 0. And so I'm going to go ahead and bring down my inequality symbol. And what I have is I have a statement such as 0 is greater than 61. Now what I'm hoping you notice here, and I should have wrote that in red, I'm hoping you notice that this is a false statement, right? Is 0 really greater than 61? And the answer to this is no, this is actually a false statement. So this situation is going to be a situation where we have no solution. We didn't have a variable, we were given a false statement instead. So this is no solution. Now because we ran into this, I want to talk to you just briefly, and I'm not going to do problem number 10 because I think it looks very easy compared to something that we've already done. But I want to go ahead and talk to you since we have a situation of no solution. I figured this is a perfect time to talk about no solution, infinite solutions, and one solution situations. What I want you to remember is that I'm going to draw a graph real quick. If we have a situation where we have no solution, what we have is we have two graphs that are parallel to each other. In other words, there's no point at which the two lines cross. When the lines don't cross, they're parallel. There's no solution. Now, on the other hand, in most cases, you're going to have x is greater than something or x is equal to something, depending on if you're doing an inequality or if you're doing an equation. And when you have that x is equal to something, well, then you have one solution. So I'm just going to draw a situation where we have one solution. If I were to draw two lines crossing, the point at which they cross, that x value would be one solution. And that's when you have x is equal to some number. One solution, right? Because there is a point at which two lines intersect. You have a third situation that can happen as well. I want to talk about it. You know what? I should have made this box just a little bigger. So let me fix this. So when I talk about the next one, it's going to be what we call all real numbers or infinite solutions. Sometimes what happens is you're given a graph, and even though the equations look different, they represent two lines, and I'm going to do them in two different colors, but they're two lines that lie on top of each other. So they're equivalent equations. They may look different initially when you're looking at them, but they're two of the same equations and they lie on top of each other. And therefore, in this situation, we like to say that the answer is all real numbers. Notice I'm putting the number sign instead of the word. It's just short of the right. But we also call that infinite solutions. So in Algebra 2, we normally call it infinite solutions. On Algebra 1, they're going to call it all real numbers. Even on the STAR test, I've never seen the word infinite solutions on the STAR test. They'll usually say all real numbers. And that just means that the lines lie on top of each other, so every single value of x is a solution. And the way you can always tell that it's all real numbers or infinite solutions is you'll get an answer that looks really odd, and it'll be, for instance, you'll get something like this. 0 is equal to 0. In other words, which is true. This is a all real numbers or infinite solution problem. When there's no solution, you get something that's false. In this case, we had 0 is greater than 61, which is clearly false. Or we might have something like 0 is equal to 5. So that would be no solution because it's false. Now, if we have a solution and the lines do cross, they will only cross at one point when there's one solution, right? Which is going to be most of the problems that you solve, and it'll be x is equal to some number, right? It could be x is equal to -5, x is equal to 3, but there's just one point at which they cross. Okay, now that we're here, I did decide to go ahead and do number 14, and I'm going to tell you why. Because I don't remember if we did one where there was no value in front of the parenthesis, but we had a negative sign. And I want to make sure that you understand what that actually represents. So we're going to get to it, but first let's go ahead, because we're going to work from left to right. And we're going to start with using the distributive property on the left to go ahead and get rid of this constant value of -2 by distributing it to what is inside of the parentheses. So here we end up having -2 times 4x. So I'm going to come over here and I have -2 times 4. So notice that's a negative times a positive, so it does become negative, and we have -8x. And then I have -2 times +7. So I'm going to write that down, -2 times +7, and that's going to give me -14. And this is going to be equal to, and notice I'm just going to bring this constant down. It's all here all by itself, +9. But notice now we have this negative sign in front of the parenthesis. And if that looks confusing to you, don't worry, it's a very simple situation. Anytime we have a negative sign in front of a parenthesis, just like there's an invisible number in front of every variable, there's a invisible 1. There is an invisible 1 in front of this parenthesis. If you see a negative sign there, you need to remember there is a 1 there. So I'm going to circle it. So we're going to multiply -1 to both terms on the inside. So in other words, I have -1 times 8x. Now the neat thing about knowing that there's a -1 here is just remember that whenever you multiply anything times 1, it's going to be itself. So the only thing that really changes is going to be the sign. So anytime you have a -1 in front of a parenthesis, you just got to change the sign of both values. In other words, this would become -8x and this would become -23. If this were a -23, it would become a +23. But I'm going to write it out here still so you can see the operations that's occurring. So this is -1 times 8, right? And if you're not sure about your signs, you can always check it in a calculator. -1 times 8, you're like, oh yeah, it does. It equals -8. So I'm going to go ahead and I'm going to write -8x right here. And then I'm going to go ahead and I'm going to multiply this -1 to +23. So -1 times 23. And remember, a negative times a positive is just going to make it negative. So when I multiply this out, it just becomes -23. So in all honesty, you don't have to write this out like I do. I'm writing this out so that you can see that operations are occurring. We are distributing and multiplying. But if you just remember, oh, there's a negative up here, I just need to change the signs of everything that's inside the parentheses. That'll work too, right? This became -8x. This became -23. Now, let's go ahead and go to the next part of this, right? We have to combine some things. So before we go any further, I see that I have a +9 and a -23, and I want to combine those before we go any further, and then write it down there. So I'm going to come over here and put +9, and I'm going to combine it, so I'm adding it to -23. And I have -14. So that becomes -14. I'm going to simply just bring down my -8x. And this is equal to, I'm going to bring down my -14. And I'm going to bring down my -8x. Now I can tell you just looking at this, I already recognize that something's going to occur here. I'm looking at it and I see that I have a -8x on both sides. And I have a -14 on both sides. So I can tell you right now, this is going to be infinite solutions, or what we call in Algebra 1, all real numbers. Because when you combine this, it's going to give us that situation that we seen earlier. I was showing you an example where we have 0 is equal to 0. And that's because if I were to graph each side of this equation, I would have two lines that intersect. Because I told you that all along, anytime we've been solving an equation, we're really just looking at the point of intersection of lines. But these are two different lines. But they're I say two different lines, two separate lines. However, they lie on top of each other. And so I'm going to go ahead and finish this off so you can see what I'm talking about. And you know what? I think I'm going to jump over and use I'm going to use the calculator so like you can see what would happen if I graphed it. For instance, I got -8x minus 14, -8x minus 14, and I'm just going to graph both of these. I'll click down and I have -14 minus 8x. -14 minus 8x. And if I hit graph, you're going to see the line change colors. We had one line and then the second line is right on top of it. If I hit second table, you can see that I have two different lines, right? This blue one represents one line. The Y2 represents the second line. And notice that when you're looking at the X value, it's saying that we have the same value twice. And that's because there are two different lines lying on top of each other. And so this is going to be all real numbers. But let's do the math so you can see how it turns out. I'm going to add 14 to both sides. So my constant value is 0. I'm going to simply add 8x to both sides. And this is 0. So I end up with 0 is equal to 0. Notice I don't have an x. So there's not one solution. It's all real numbers. And that would be on a STAR test. If it's multiple choice, you would choose the one that said all real numbers. Now, if your teacher's asking you in class and they've already introduced you to the term infinite solutions, you could also say that it's infinite solutions. Both terms are synonymous. They're both correct. All right, let's do our final problem. I'm going to move this up. And in this one, it wants us to solve for y. So we're going to do that. Let me go ahead and clear this graph real quick. Now, when they say solve for y, your goal is actually to just get y isolated by itself. So I'm going to put on there isolate. So you want to move everything away from y, everything away, on the other side of the equation. So we're going to do that real quick. I am going to draw my line through here. And if I want to get y by itself, before I can divide out the negative 2, I have to move the term of 5x over to the right. And the reason that is because when we're doing inverse operations, right, it's the opposite operation. Not only do we go ahead and use inverse operations, but I want you to think about operations operating backwards. In other words, we take care of addition, subtraction first, and then we take care of division and multiplication. So right now, this is a positive 5, right? And so to move the positive 5x over to the right, I'm simply going to subtract it. So 5x, I'm going to subtract 5x from this side. We do run into a dilemma on this right side. And you know I should have done this in black because it is a variable. The dilemma we run into is there's no variable to subtract it from over here. So just remember that there's always a 0 over here as well, right? Imagine it says plus 0. And so we cannot subtract a variable from a constant. They are not like terms. They do not get combined. So what we're going to do is just rewrite them. So I know my variables become 0 over here for the x. And now what I'm going to do is just rewrite this. Now when you rewrite it, I always like rewriting the variable first. So I'm going to put minus 5x. And then I take the constant value, and that's a positive 6 because it doesn't have a negative sign in front. And I just bring it down and write it at the end, plus 6. And then I'll simply bring down my negative 2y. Now notice that's a different variable, right? It's not the same. And we're almost done here because our goal is to get y by itself. Our goal is to get y on the left side and everything else on the right. Now I do have one more step. I do have multiplication going on here. Negative 2 is being multiplied to y. And so I need to go ahead and divide by that coefficient of negative 2 to get y all by itself, where it just has a coefficient of 1. So I'm going to divide by negative 2. Now here's the thing. When you go over to the right, I know sometimes I'll see people and they'll draw a division sign and put a 2, a single negative 2. And a lot of times they'll forget they have to divide into both terms. What I recommend is anytime you have addition or subtraction going on between terms and you're dividing something out from the other side of the equation, go ahead and just write yourself two different problems. In other words, go ahead and show that you're dividing negative 2 into the first term and you're dividing negative 2 into the second term. That'll help make sure that you don't forget to divide the negative 2 into both terms. So I recommend that you do it this way. Just break it up. And when I say a term contains a sign. So negative 5x is one term. Positive 6 is a second term. So we're going to go ahead and do the math. Anything divided by itself is just 1. So that leaves us with simply 1y is equal to. Now there is going to be a change in sign over here. I want you to notice we have a negative being divided by a negative. And you might be tempted to just rewrite this down here because you may know, say, you know what, I know 2 won't go into 5 evenly. I can just leave that as an improper fraction, which would be fine, especially in Algebra 1, right? Because you're going to graph this, and it's nice to graph when you have a fraction. But you do need to take into account that those signs are going to change things. So for instance, I'm going to go ahead and use my alpha y equals and option 1 to get my fraction bar. I'm going to go ahead and put negative 5 in my numerator. And I'm going to put negative 2 in the denominator. And I want you to watch what happens when I hit enter. So negative 5 over negative 2. Notice it changed to 5 over 2. So you have to change that sign to a positive value. If you don't, it's going to be considered incorrect. So you have 5 over 2x. And then we have 6 divided by negative 2. So I'm going to go ahead and put 6 divided by negative 2. And that gave me negative 3. So that actually became an integer. So negative 3. We didn't have to deal with a fraction. And this is my final answer. Now just like you see me using this regular divide sign, I could have went negative 5 divided by negative 2. The only reason I didn't is because then it just gives me a decimal. And not that the decimal is wrong. In other words, whether you have y equals 5 over 2x minus 3, or whether you have y equals 2.5x minus 3, honestly, they're the same thing. Unless your teacher tells you you have to leave it as a fraction, it doesn't really matter which one you write. But I'm going to be quite honest with you. If this was a multiple choice question on a STAR test, they're going to leave it as a fraction. They love leaving things as fractions. And if you were going to have to graph this, I would say definitely leave it as a fraction. Because if you leave it as a fraction, then this 5 is your rise and the 2 is your run, and it makes it really, really super easy to graph it. So I'm going to go ahead and say this is the answer, but if you got this, well, this is correct as well, right? It's equivalent. It's just written as a decimal instead of a fraction. But if you want to keep it as a fraction, just use that alpha y equals and option 1, and you can always leave it as a fraction, right? The only time that it won't is if the number will divide into it equally. Like for instance, the 6 over -2, since it divides equally, it's going to tell you that it's an integer, right? But if it can't be divided, it'll leave it as an improper fraction or a fraction. So this is it. That's everything that you need to know to be successful. And if you have any questions, continue the review and just ask me in class and I'll do my best to help you.